Hey everybody, we'll jump into it. I'm Andrew Harris, I'm with ZoomInfo. We provide a lot of B2B data for sales professionals to find the people they need, the interactions they need, the intent they need. Anything in the signal space we're probably working on. I'm a senior manager of software engineering and I work a lot with free web spaces. So spaces you can just stumble into on the internet, things you can see, SEO, that sort of thing. And I work with some really, really talented engineers. And the folks here at Zeit have been a part of our success as well. So first, what is a complex web space, right? So just thinking in terms of human stuff like rooms, like a really big room with a lot of people in it, or maybe like a shop, right? You want one item, you go in, you get it, it's congested, it's more challenging than it should be. Most of what we're looking at in a complex sense, it's things like social media, search engines, indexes, things of that sort. Anything that's made available by professionals for consumption. They're complex because the larger they are, the more robust their resources are. From a policy and monitoring perspective, that can create some interesting challenges. Obviously, keeping everything polite is a really, really huge focus of pretty much everything we want to do. We don't ever want to hug anything to death or violate anyone's privacy rights or collect information that we shouldn't be collecting based on the ethics of the site and our ethics as a company. So just a few examples. I've already talked about a couple of these, but just getting a little bit more in depth, right? So if we think about social media interaction, who folks are interacting with, how they're interacting, timing of interactions, those sorts of things. Real-time search behavior, so how search engine results are containerized, how search engine results are visualized, how they're made available to you as the searcher. Those contain some really interesting kernels of insight. Observation of trend analytics, not like trends data itself, but what do we see happening in these various spaces? How can we learn more about why those actions might be happening? I found the alternative data presentation particularly interesting earlier. There's a lot of things like that give you really, really interesting things to go and learn more about, which takes us into that trend relevant content listening, right? If you see something interesting, you might want to go and learn more about it. And so having a dynamic way to respond to those sorts of interactions is also an important use case for us. Democratization is a big thing. I don't know if it's globally a big thing, but for me and for our team, it's a big thing, right? Like, we shouldn't have to have someone with a PhD doing literally everything. There's a lot of opportunity to sort of lower the barrier for entry for a lot of these systems. A lot of what we were looking for specifically as a group focused on scaling use cases that we were already interacting with. Sorry, lost my train of thought here. Scaling use cases we were already interacting with and allowing folks who don't have advanced engineering experience to really get in there and actually affect change. How could we take maybe an analyst who isn't necessarily code focused and give them a way to interact with these systems pretty intimately? So that takes to the core problem, right? How can we architect a modular system for web interaction and web extraction that we can kind of democratize to as many users as possible? And so when we first started out to do this, we wanted to look at shared objectives, right? Like, what is everybody looking for? I mean, it's no secret, HTML is a huge component of this. And so a lot of our extractions are standardized on that sort of thing, right? So how we interact with that once we get it back from the web, how we store it, how we make it available to our users was a huge focus. Pretty much everything, as I mentioned, is fairly standard. We have a lot of use cases that really overlap though, right? So if you think about a group of maybe 100 distinct engineering teams, you may have very, very niche needs to use very, very similar data. And so finding a way that we could create a resource that would put all of that in one place without increasing the cost burden for the organization was really important to us as well. And then low-code environments. As I said, we're trying to get as many people as possible comfortable with using this sort of tool, interacting with it, making it work for them. And so really early pain points, right? So back to the complex web spaces. There were a lot of cases where we find those interactions to be more challenging than they necessarily should be because of simultaneous movement, right? Like, if we have several teams interacting with similar resources at the same time, it creates a really increased risk. Left hand isn't talking to right hand. You can have situations where a lot of that data the burden on the website becomes too strong, the burden on our systems becomes too strong, the burden on individual users trying to work with that data also becomes too strong. So individual extraction limits, going back to that, how do we play nicely with the folks that we're interacting with? Making sure we're building polite crawlers, and really focusing on demand levels in specific times, and queuing in such a way that we're not, like I said, hugging a website to death or creating an unnecessary burden. You know, not everything needs to be read this minute, despite what your product leaders will tell you. And so figuring out how to do that in a fair way that works for everyone was a focus. Hygiene. Most of the data that comes out of the internet is not well structured. So that's an independent challenge of itself. Each team interacting with this data, in many cases, has their own specific way that they want to interpret hygiene. And so having a more genericized raw resource that can be made available across the organization gives us an opportunity to implement specific hygiene protocols for specific groups at specific times. And then low-code environment. So if you don't code a lot, how you understand functionality is probably going to be a byproduct of outputs, right? Like what you see coming back to you is going to be your biggest signal as to whether or not the thing you're interacting with is working the way you want it to be. There's a lot of things that can cause that to be true or not true, but the interpretation is the piece that's important. So when we started thinking about this and we started looking at how we might do this, we quickly realized that timing was pretty much the entire game, right? Like, given an unlimited amount of resources, you could probably get most data out of whatever website you want, but putting it in a time box and doing a couple 100 million of these per month or per week, it creates constraints, right? And so when we were looking at that, we considered extraction protocol, like that notion of do we need to read everything always? And the answer, like I said, is no. And so how a user deploys their specific implementation, how a user modularly demonstrates their extraction needs, that's going to have an impact on how long it takes these things to get through the system. So we rely on weighted fair queuing and dynamic feedback. So there's those users that, regardless of training, will always assume that their data needs to be read quickly right now in that second kind of thing. And so that can create some spam behaviors. And so how we individually associate where someone falls in a queue or where a particular job falls in a queue is dynamically related to how their previous jobs are functioning, what sort of feedback we're seeing from websites, what sort of feedback we're seeing from users. Essentially, it's a real-world way of trying to implement politeness in cases where that might not be the number one concern for the user. So this is a little model of how this looks. You know, there's several chunks here, and I'll talk through some of these chunks in more detail. Diverse set of users throws some stuff into an API that we've created, data on demand. And then from there, we route through a job planner and then an actual router that does a lot of clever things that the team has worked out here. And then everything kind of comes back together at the end via this executor that simultaneously runs the thing and also publishes the results back for users to consume. And you see there's a diverse set of modules over there that we could interact with. You know, some of these things may be proxy engines, some of these things may be traditional scrapers, vendor data sets, all sorts of things like that. Okay, so planning jobs. As I mentioned, everything is API. So when we plan, we do a few things. We plan, we chunk, we route, and then we reassemble. And so going back to that low-code notion, right? A user submits a series of hints or metadata that basically tells us what specific kind of module they'd like to use. It's a pre-programmed module that an engineering team's released. And then from there, they can modify what specific elements of data they'd like back based off of pretty generic headers that we'd find in a lot of models, right? And so the chunking component, initially everything gets broken into fairly standardized blocks. Those blocks are dynamic. As things flow through the system, we see a lot of alteration, right? You know, if there's a lot of traffic or we see response changing in a way that we didn't expect or things are more dynamic than we thought they were going in, that can flex one way or the other. Routing is simply taking that job metadata from the user input and making sure things end up where they should be in the module. You know, that metadata is going to tell us things about what level of specificity do you want on headers that you're pulling back? What levels of specificity do you want on headers that you're looking for initially? That kind of thing. And then reassembly, you know, that lives in the reassembler itself. The router has a bit of functionality there also. But that takes everything that we've sent through the system, zips it back up into one package, puts it in a place that is usually specified via metadata or standardized, and then users can stumble along later and grab their data. To get a little bit more in depth on the router, a little bit about tech stack. Tasks include scheduling, stopping, and routing, right? So just like I mentioned previously, we set out with an initial schedule. We expect it to work based on rules-based engine. It doesn't necessarily happen. And so often we have to stop these sorts of things. Again, all dynamic built in. Based off systems feedback, we see various ways that we need to manipulate that system to avoid violating our politeness rules, so to speak, or crashing something or overtaxing our infrastructure. Routing we covered in the last slide, and then the weighted fair queuing system. Really big fan of that. If you're not using it and you have anything that uses a lot of users, please think about it. And then actually executing the query blocks. Every query module, and there's like maybe, I don't know, there's a couple hundred. So every query module that we have essentially has a specific group of things it's meant to return and a specific group of things it's not meant to return. And so how those modules are implemented may vary slightly from job to job. There may be certain pieces of data that are being extracted by a module by one user that are disregarded by another user. The important thing is that it's stored in raw form, and then people go back in later and access that raw data if they need it. But typically, the module itself determines what you're getting back, how you're getting it based off that metadata. And then the query executor, it makes decisions about leanness, timeout times, what sort of header protocols to use, based off what it's seeing dynamically coming back from the web. Everything is stored in a cache. So one of the things that we ran into, mentioned earlier, disparate users are creating really similar requests in a lot of cases. And so finding some way to genericize that in such a way that you're basically not paying to go and get the same data every single day was important. Figuring out how to take timestamps or specific time blocks and assert, okay, for your specific use case, based off of the corner of the business that you're working in, this is probably a decent enough cadence. What do you think? Yes, no, we'll push back a little bit. But the same module could have varying lengths of, could have varying implementation strategies and varying return strategies. And so checking that user cache, that results cache, is going to be pretty important. In many cases, I think it saves about 40% of what we're running. So again, I'd recommend that if you're not looking at it. It was a little tricky to wire up because how a user submits a job may create some entity resolution challenges when we go to look at those results caches, but we found it to be a problem worth solving. Spoke enough about execution time. And then, as I said, everything gets routed back through Job Router at the end, zipped back together in a really decent package, and then folks come along later and they pick up their data. So it's my last slide, talking faster than I expected to be. Where do we go from here? We're starting to incorporate more machine learning in how we interact with these. You know, I said these things were dynamic, but they're not anywhere near as dynamic as they could be, right? Teaching the thing to think in a more dynamic way for itself is going to further reduce engineering burden going forward. Generalization of HTML, you know, agnostically parsing HTML based off header attributes so that there is even less need to actually program specific items that we're going for is on the docket. Pattern detection, I'm not going to talk about that. Most of the people here kind of understand that. Dynamic code structure for agnostic understanding. LLMs, had to work that in. That's been a theme today. And so figuring out what we can do from a parsing perspective using these language models as they roll out, figuring out what prompt engineering means in the context of these language models, that's a frontier we're excited to explore as well. So that's it. Thank you all.
What was the hardest problem you had to solve with all of this?
I think it was, I'm going to basically say the entire project, but the dynamic queuing piece was really challenging early on. Like, we didn't really have a good understanding of, similar to, like, I imagine some of the challenges you guys probably see with Smart Proxy. It's like, how do we make everything play nicely when there's so much of a bottleneck that things will just break? So we talked to a bunch of architects, and we got some really good feedback there. So that, and I'm hesitant to say it's solved because every month or two something else will crop back up, and we'll have to go and play whack-a-mole. But
And what about making the whole thing open source?
Ooh, that's a tough question.
You can blame one.
Okay, I'm gonna take a pass on that one. It's not because I don't want to.
All right, and you know, Constantine is asking there about what sort of jobs are people submitting. Some examples.
I think every example that we've seen today kind of falls in a similar bucket. You know, a lot of what we deal with is business data published in an open space, right? Like if you're putting data out there and you're a CEO of a company, that's the kind of data we're going to go look for. If you're looking for intent data, like if somebody's saying things very, very clearly about your product on the web or in news sources, we're probably going to see that sort of stuff too. We're not in the fridge game yet, but maybe one day.
And are you distinguishing in your requests between the kind of classic browserless and browser rendering challenge in going to get the data?
Yeah, so if there's user awareness, then that's often specified in job metadata, but if there's no user awareness, we're doing some of that on the back end. There's some headless solutions that are implemented. Depending on the nature of the website and what we've seen previously, we can adjust the approach pretty. I would say I've said dynamically a lot. We adjust the approach as the job's in flight. So yeah.
Okay, cool. All right, we've a couple more questions here. So just hit the one at the bottom there about what are you using for observability and issue triage? Kind of two different points, but.
I don't want to name names, but I'm going to. We do a lot of stuff with like SL data or something like that, monitoring systems based off input. Once a job runs once, we'll sit with the user and sort of say, like, what did you expect here? Like, what's a normal range? How often do you expect somebody's name to be Mickey Mouse or something like that? And then we'll go and set some triggers with a tool like SL data. There's another one that's just showed up on the block that I can't recall the name of that one. But there's similar monitoring tools. Basically, we set thresholds for what we expect from a behavior perspective, and then if something just shoots through the roof or collapses, we'll get an alert.
Okay, cool. All right, so a couple more. We have a bit of time, so we can keep going. Okay, jumping around here. Okay, so I'll take the second one here, which is, what is the part of your decoupled system that became the bottleneck, and what about the one that scales out the most?
It didn't used to be a decoupled system. That was the bottleneck. And so having to go and fix that. When this was originally, this exponentially grew. So when it started, it was a fairly small POC project that very quickly turned into a productionalized project and then very quickly hit a bunch of challenges. And so I'd say that's probably my answer there.
You alluded to during the talk, and I see it here in the question about the tech stack, and I suppose can you talk a little bit more about the tech stack and any kind of strengths, weaknesses, and various other things?
I put as much information in the slide deck as our CTO office was comfortable with, but I'm happy to chat with people if you want to maybe talk a little bit about what's worked for me, what hasn't worked, what's worked for you, what hasn't worked for you.
Okay, I think the second question is probably similar to that as well. I do have the same question that I've been kind of asking everybody. If there was one part of this whole kind of problem that you could just make go away because it was just painful, is there any particular thing that you'd just love to make disappear?
Yeah, I think for me, and I don't know how many of my colleagues would answer, to me it's the agnostic HTML parsing. Once we're able to get to the point where the model dynamically understands those structures, interprets those structures, it's going to further lower that barrier for users, right? And so for me, finding a way to genericize that as much as possible, similar to like a data struct or something, that's kind of what I'm after at the moment. So.
All right, brilliant. Well, thank you very much.
Thank you.